Okay, we're looking at exercise 5, mixed exercise 5 from the core first year textbook. So it's in straight line graphs. We're up to question 13, so an exam question. So that's always helpful so we can see how many marks each bit's worth. It's also problem solving, so you might have to think carefully about our method. Okay, so find the equation of the line passing through these two coordinates, and we're asked to give our final answer in that form. Okay, so that's not a bad start. So I'm going to get the gradient. So gradient change in y, so I'll do, it doesn't matter which way around I go, I'll do this coordinate, take away this coordinate. So it's going to be 5 minus 2 over minus 1 minus 4. Yep, so y coordinate minus y coordinate over x coordinate minus x coordinate. So that is going to give me 7 over minus 5, so minus 7/5 is my gradient. Then I'm going to use y minus y1 is m times x minus x1. It really is much easier than using y with mx plus c. I can use either coordinate. Don't think it really matters. They've both got one positive and one negative. So let's use the coordinate A, or the first coordinate, so minus 1, 5. And then I've just got to sub those in. So there's my gradient. There's my x coordinate. And there's my y coordinate. So it's going to be y minus 5 is minus 7/5 times x minus 1. So that'll end up being plus 1. They want a, b, and c to be integers. So I'd normally do this anyway, but I'm definitely going to multiply through by that 5. So if I multiply the left hand up by 5, I get 5y minus 25. If I multiply the brackets through by the minus 7, I get minus 7x minus 7, and they want me to rearrange it to this form. So if I add the 7x over to the left-hand side, I've got the plus 5y, and I add the 7 over, I get that. Okay, so that's not too bad for 3 marks, quite a standard question. Okay, so we've seen this come up a couple of times already. They want the area of a triangle. I definitely want a sketch, I think, for this type of question. Okay, so the line crosses the x-axis at A. Okay, so if you think about where, well, I'll tell you what, let's just do a rough sketch of this line. So it would have, if I rearrange that, well, I know the gradient. I know that the gradient is minus 7/5, so it's got a negative gradient. And it would have a positive y-intercept. So not drawn to scale, but let's say it looks something like that. Okay, so it crosses the x-axis at A. So that's A, and the y-axis at B. So A is where y is 0. So at A, y is 0, so the equation will become 7x minus 18 is 0. So 7x equals 18. So I think it's one of the first questions we've seen that's got lots of fractions on. Hoping that doesn't mean I've gone wrong somewhere. Assuming I haven't. So that is 18 over 7. Okay, what's happening at B? Well, B is where x is 0. So again, if I go back, I'm going back to that equation highlighted. I'm going back to that equation highlighted in yellow, and if I substitute x is 0 into that, I get 5y minus 18 is 0. So 5y is 18, so y is 18 over 5. So that's the y-intercept. Okay, and then so once you've got that, it's then fine from there. Obviously, that's a right-angled triangle. So the base is 18 over 7, and the height is 18 over 5. So the area of that triangle, it's a mess to try that again. Okay, so the area of that triangle is half times base times height. So let's try that. So half times base times height is giving me 162 over 35 square units, or 4.63. Yeah, it didn't mention exact area or not. Right, let's hope. Yep. That's great. And yeah, we've got pi as well.